Hi, in the previous video, I showed you how to use the tree diagram method. Using the tree diagram method, it is easy to classify the observations, imaginary observations into different outcomes. And then you can recover the frequency distribution table. Then from there, you may calculate any probability you want. And now let's study what is behind it. So the principle flowing behind the tree diagram method can be written in this way. I will go backward from the result where we got the numbers. So think about this. We just calculated the probability of defect, and it was calculated in this way. Out of 1,000, there were 12 domestic and defective batteries plus 28 imported and defective batteries. And then where these numbers are from? 12 and 28. It's easy, clear. Number 12 is from, it's calculated as 2% of 600, right? There were 600 domestic batteries, and of them, 2% were defective. That's how we got 12. Similarly, 28 were calculated as the result of 7% of 400 imported batteries, right? So, and these numbers, 2% and 7%, were the probabilities given in the question. So now we see how we got those numbers. Then where did 600 and 400 come from? The answer is 600 is obtained as the result of 60% of 1,000. So one of the informations we had was that 60% of the batteries are domestically produced. So that's where we got 60%. And 1,000 is the number we assumed. So 600 is the result of 60% of 1,000. Similarly, 400 is the result of the probability of imported batteries times the total number of batteries we assumed, right? So then we have 2%, 60%, 1,000, 7%, 40%, 1,000, 1,000. We know all these numbers but 1,000. So 2%, 60%, 7%, 40% can be replaced. They are from the information is given in the question, right? We used 2% because we assumed that the conditional probability was 2%. If this probability was 3%, we would have used 3% here. So we may generalize 2% to this guy. 60% was the probability of domestic batteries. In that way, 7% was the defective rate among imported batteries, and 40% was the probability of imported batteries. But 1,000 was just a ad hoc number. It means nothing. I just chose because it's easy. But it doesn't matter because you can cancel out. Cancel out 1,000 from the numerator and denominator. Then in the end, we have this equation. This is the essence of the tree diagram method. So we may extract this formula from what we have done, and let's formulate this rule. The main purpose of this rule is to recover unconditional probability from available conditional probabilities. And we have probability of B and conditional probabilities of A given B or B not, B or B complement. So, and then we can calculate the probability of A in this way. That's I just used. So exactly symmetric to the previous example. A means defective, B means domestically produced, B complement means imported, right? If you match one to one, then it's exactly what we have this. I just used different notation for general formula. For any A and B, we have this formula, this rule. There is no specific name for this rule, but still it's useful, very useful. Another way to understand this rule is that you may understand it as a weighted average. So imagine this. We are looking for the overall probability of defective batteries. Among batteries, there are two different types, domestic ones and imported ones. So think about two groups. There are two groups, and we would like to calculate overall defect rate. But what we know is the defect rate for each group, and then you can easily think that the overall defect rate is a weighted average of these two within group defect rates, right? We have two defect rates for each group, and their weighted average is the overall defect rate. And in particular, what we just derived shows that the weights equal to the probability of each group, which is natural. Because if a group is more likely to happen, you have to put more weight on them. And if a group is unlikely to happen, then you have to put a smaller weight on them. So in that way, in the end, you have overall probability of A is weighted average of two conditional group-wise, group level probability with specific weights. The weights are probabilities, right? In our example, domestic defective rate was 2%, and imported defective rate was 7%. And then intuitively, the overall defective rate is somewhere between 2% and 7%. And if 100% of the batteries were domestic, then the overall defect rate will be 2%. Or if the probability of domestic batteries approaches to 0%, then the overall defect rate will be close to 7%, right? Somewhere in between 2%, it's just weighted average. Where is the overall average? It depends on the ratio between domestic batteries and imported batteries. So this was how we could recover the unconditional probability from conditional probabilities. So we are going to study another different topic in the next video. Thank you for watching this. See you in the next video.